So you're given an integer array and an integer k. Your task is to return k most frequent elements. Now look at this example 1. You have 1 and that appears 3 times. You have this 2 that appears twice. And you have this 3 that appears once. So the top 2 most frequent elements in this are 1 and 2. Right? Let's take the same example and let's try to build some intuition here. Now, what's the most basic way that I can solve this? Since this deals with the frequency of the numbers in the array, I can definitely count how many times each number appears in the array. That part is pretty straightforward. So, we just need to traverse through the array and build a frequency map, where in your hash map, your key will be the number and your value will be the frequency. So let's say this is your key, this is your value, your number is 1, 1 appears thrice, so you add that to your hash map. Then comes 2, that appears twice, add that to your hash map. Then comes 3, that appears once, add that to your hash map. Now this is your frequency map. But then comes the real question. Now how do I figure out which ones are the most frequent elements here? The easiest answer would be make this key and value as a pair and sort these numbers, sort these pairs by their frequency. Once you sort it, you can pick the top 2 and return it. If you sort these particular pairs in here, what do you get? You get 1, 3. These are key value pairs, 2, 2 and 3, 1. It indicates 1 appears 3 times, 2 appears 2 times and 3 appears 1 time. And you've sorted it by frequency. The highest frequency comes first, right? Now you can just return top 2 in this case and you'll get 1 and 2 as your answer. You can sort the numbers by the frequency and pick the top k. This works perfectly. But the issue with this is the sorting step takes O of n log n. Right? Sorting takes O of n log n, which is not ideal when n gets large. So now what do we ask ourselves to get to an optimal solution? Now let's flip the question entirely. What if I don't want to sort and avoid this n log n complexity? Can I avoid sorting altogether and still find the top k frequent elements? Instead of sorting, can I probably group these elements by how often they appear by their frequency and grab the top ones directly? That's where the idea of bucket sort comes in place. So basically, given array, we start the same way. We build the frequency map, right? It is so far, it is same as the brute force approach. But now we do something different. Instead of sorting, we now ask, what if I want to use a list where the index of that list represents the frequency? What does this mean? All numbers that appear 3 times, let's say this is our list, okay, and we have our indices. Now what did I mean when I say I want to use an array where the index represents frequency? That is, all numbers that appears 3 times come under this index. So in this case 1 comes here. Now all elements that appear twice go to index 2. So 2 comes here. All elements that has the frequency 1 that appears once go to index 1. So 3 comes here, right? So this is the formation of something called buckets in this case. But we should know how big this array should be. So think about this. Let's say this is not your problem. This is your problem. Input array is this, all ones, 6 ones. Now 1 appears 6 times. Now if we construct a bucket array of the same size as the given array, we'll have only 5 indices, right? Because it's 0 indexed. So you can't accommodate this sixth frequency, this sixth, like 1 appears 6 times. You can't handle that case, which is why we should always create this bucket array of size length of nums plus 1. The given array size plus 1. So that ensures we can index from 1 up to the maximum frequency without going out of bounds, right? And now let's come to another edge case. What if your given input is 1, 1, 1, 2, 2, 2 and 3? In this case, 1 and 2, they map to the same index, right? They both appear 3 times. Now, in this case, what do you have to do? You can't have a single integer, right? You need to have a list of lists. So your buckets would be something like, this is your first 0th bucket, first bucket, second bucket, third bucket, fourth bucket, fifth bucket and sixth bucket, right? 0, 1, 2, 3, 4, 5, 6. Now let's fill this bucket. Okay, let's fill this list of lists. You see a 1, one appears 3 times. So what do? You go to your index 3, add 1 here. Now you see 2, your 2 appears 2 times. You go to your index 2, add 1, add 2 here. You see your 3 appears once. Go to your first index and add 3 here. Now what do? How do I get the top k elements from this setup? We just walk from the end of the array towards the beginning and collect elements until we reach k elements. For example, in this case k is 2. So we start at index 6, it's empty, we move on. Index 5, empty, move on. Index 4, empty, move on. Index 3, we see a 1. So to our result array, we add a 1. Index 2, we see a 2. So we add 2. Now we've reached k is equal to 2. So we just return our 1 and 2. Now in this case, we don't need any sorting and it's done in linear time. Alright, let's define our function now. So first step would be to build the frequency map. So let's initialize the same. Now we need to count how many times each number appears in the array. So we need to traverse, and if the number is already in the map, we just increment its count. Otherwise we set its count as 1. So it's there, we get its value, divide 0 and increment it by 1. Now we have our dictionary, we have our key and value pairs. Now we need to use our buckets. We need to create a list of empty lists. That index will represent the frequency, and we need to use length of the given array plus 1, because that highest possible frequency case that should be handled. So let's create our bucket array. We initialize the list of lists, and that should be plus 1, right? Now once we have this bucket array as well, for each number and its frequency, we'll have to populate number and frequencies into their appropriate buckets. So if a number appears 3 times, then it needs to go into the third index of the bucket array. So let's do that now. And it should be frequency. No. Okay. Now we have to go through the bucket array from the end to the start. That way we'll collect elements until we have top k of them, right? Most frequent. So first we need to initialize our result array. Now we need to start from the end. We need to start our traversal from the end, right? Sorry, my bad. Yeah. Now that particular list can have multiple numbers as well. So we need another loop here, and what do we have to do? If we see anything, we just have to append that to the result. And at this point, we'll have to check if we already collected k elements. If this is already k, then we just return our result. Now let's try to run this. Yeah, this works. So if to quickly break it down, we build a frequency map that takes a linear time complexity of O of n. We fill the bucket, that takes another O of n. We scan the bucket array from the back, that takes another O of n. So in total time complexity for this would be O of n, and space complexity would be O of n, because we used a hash map and the result array. And when you compare it with the sorting time complexity, which is O of n log n, this is much better, right? So I'm currently working through the blind 75 series. So if there's a problem that you're stuck on, drop it in the comments and I'll cover it next. Until then, keep grinding and I'll see you in the next one.